Let us do one more problem on mesh analysis. Find mesh currents I1, I2, I3 using mesh analysis method. So there are identify how many meshes are there. So this is a mesh number 1, mesh number 2, mesh number 3. Okay, three meshes are there, I1, I2, I3. All are clockwise only. Please note down, all are clockwise only. And this is minus, this is plus. So smaller one is minus, and this is clockwise, no? So for I1, this is plus minus, plus to minus. For I2, this is plus minus. This is voltage, no? This is plus to minus only. This is plus minus. This is voltage. This cannot be changed. This is plus to minus, and this is plus to minus. Now apply KVL for mesh 1. Apply KVL for mesh 1. So this is start from 1. So this is 1 is at the edge. 1 is at the edge. This is first plus. Okay, first plus 1 into only I1. 1 I1. This is 1 I1. 1 is you can write, otherwise you leave it. This next we got minus 20. Next we got plus 2 into 2 currents are flowing. I1 and I1 and I. So I1 minus it. While writing KVL for mesh 1, you have to consider I1 is greater, because we are writing KVL for mesh 1 considering resultant current is clockwise. So I1 minus I2 plus 40. And simplifying, you are going to get 3I1 minus 2I2 is equal to minus 20. Simplify this, you will get this. Apply KVL for mesh 2. Start from 40 minus, first we got minus. See here, minus to plus. Minus 40 plus, while writing KVL, we are assuming that I2 is the resultant current and it is clockwise. So we have to assume I2 is greater. So minus 40 plus 2 I2 minus I1, and this is battery again, plus 10 and plus 2 ohms, and 2 currents are there. I2 minus I3. We have to, while writing KVL for mesh 2, you have to write I2 minus I3. Here also I2 minus I1. Okay. And simplify, you are going to get 2I1 plus 4I2 minus 2I3 is equal to 30. Apply KVL for mesh 3. Apply KVL for mesh 3. In the mesh 3, in the mesh 3, start from 2. So again, this mesh 3 current we are writing clockwise, from plus to minus only, always current. So 2, again opposite current is I2 here. So 2 into I3 minus I2, I3 minus I2, this is minus to plus. So minus 10, okay, minus 10. 4 only I3, because it is at the edge. It is not between two meshes. So only current flowing in 4 amps is I3. 4I3 is equal to 0. After simplification, you will get minus 2I3. 2I3 plus 2, 3 is, this is 2I3. This is 2I3. This is 4I3, no? This is 6I3, I think. 2I3 plus 4I3, no? It is 6. This should be 6, okay, is equal to 10. Solve equation 1 and 2 and 3. You are going to get this equation. So let us uh, write direct method I told in the last video. So this problem, please see here, this problem is having only voltage source and resistance. It is an independent voltage source, so it is easy. If it is a dependent, you have to write KVL and only you have to solve it. If they ask like this, you can do reverse engineering like this. So it is R into I is equal to voltage, V is equal to I into R. So unknown variables are three mesh currents, I1, I2, I3. So first element is sum of resistance in mesh 1. In mesh 1, how much is there? 1 plus 2. It is 3. Common to 1 and 2. Common to 1 and 2 is minus 2. Common to 1 and 3. Common to 1 and 3. It is not touching. So no element is common between mesh 1 and mesh 3, because between mesh 2 is there. So this is mesh 1, this is mesh 3. No element. So you have to write 0. 0 into I3. So that's why in the equation number 1, 3 into I1 minus 2 into I2, 0 into I3. You can write 0 into I3. Okay. Now next in mesh 2. In the mesh 2, common to 1 and 2 is same as common to 2 and 1. So minus 2. Sum of resistance in mesh 2. 2 plus 2, 4. Common to 2 and 3, minus 2. Next, coming to this mesh 3. First, I'm writing resistance matrix, voltage matrix we'll write later. So in the mesh 3, common to 1 and 3 is nothing. Similarly, 3 to 1, nothing is there. So 0. Common to 2 and 3 is same as common to 3 and 2, which is minus 2. Sum of resistance in mesh 2 is 6. And voltages, it is 20. While writing KVL, minus to 20, minus to plus, plus to minus, minus to plus, plus to minus. That we got minus 20 plus 40, minus 20 plus 40, it is plus 20, plus 20 if you bring it to right side it becomes minus 20. Left side, while writing minus 20 we got plus 40, so left side only we got plus 20. That if you bring it to right side becomes minus 20. Voltage is in the mesh 2, voltage is in the mesh 2. While writing KVL, minus 40 plus 10, minus 40 plus 10 is minus 30. Minus 30 if you bring it to right side it becomes plus 30. You see the KVL here. And while writing KVL for mesh 3, we got minus 2 plus minus 10. And if you bring it to right side, it becomes plus 10. So this is same as 3 equations. So that's what I told. If they ask only independent source and resistance, okay, you can follow this inspection method and you can rewrite these 3 equations by multiplying. So if you multiply this R matrix with I matrix, 3I1 minus 2I2 plus 0I3 is equal to minus 20, which is equation number 1. Minus 2I1, 4I2 minus 2I3 is equal to 10, is equal to 30. And 0I1 minus 2I2, 6I3 is equal to 10, is equation number 3. So now we can solve this matrix. So I can take the calculator. I will solve the equation. I will show how to do this. Mode button, equation. It is in the form of 3 unknown variables. X and Y and Z are the unknown variables. So select 2 option. So first enter 3 is equal to, then minus 2 is equal to, 0 is equal to, minus 20 is equal to, minus 2 is equal to, 4 is equal to, 4 is equal to, minus 2 is equal to, 30 is equal to, 0 is equal to, minus 2 is equal to, 6 is equal to, 10 is equal to. We entered all the values. Okay. Now plus is equal to. If I click is equal to, we'll get X is equal to 0. That is I1 is equal to 0 amps. Y, that is I2, is equal to 10 amps. And I3 is equal to 5 amps. So this is how to solve any equations. So what are the steps you have to remember is, okay, identify number of meshes. All the meshes you give with the current direction clockwise, okay, and write in the resistance plus to minus. You write the clockwise direction, no? So plus minus, here also plus minus for mesh 1. Voltage is no need to change. Voltage values will be lengther one is positive, smaller is negative. Again for mesh 2 here, this is plus minus is only for this I1. For I2, you have to write this is plus minus, this plus, this is minus. For I3, plus minus, again this side plus, this is minus. So if you write equations, we'll get this, or by inspection method you can write this and you can solve. So let us go to the next problem. Find mesh currents using mesh analysis method. So let us do one more new problem. So in this method, see, remember how many equations are required to solve the problem. Okay, how many equations are required to solve this problem is, three meshes means three equations are required. Two meshes means two equations are required. Here three meshes are there, so minimum three equations are required. So one I can get it from Mesh 1, I can write KVL here. I can write KVL for this mesh. We'll get equation number 1. Again, for mesh 2, I'll write an equation. I will write second equation. For mesh number 3, I cannot apply KVL. I can apply voltage drop here. I can apply voltage drop here because I into R. I into R, I know I into R. Here there is a current source. I cannot apply KVL for mesh 3. I cannot apply KVL. This is an important point. For mesh 3, we cannot apply KVL because there is a current source. I don't know what is the resistance here. Okay. So this is uh, actually we cannot apply KVL, and we know that any resistance in series with current source is a redundant. This is also we can remove it. Whether it is 4, whether it is 100, whether it is 200, whether it is 1000, this mesh current is 1 amp only because in series current remains same. In series current remains same, it become a redundant element. We cannot apply KVL for mesh 3, and we can directly tell that if in this any three meshes, if they give any current, see that whether that mesh is this current is between two meshes or it is independent. So it is at the edge, so it is I3 only. And see the clockwise direction. This I3 is, we consider all the mesh currents clockwise only, and this current is going opposite. So I3 is equal to minus. If it is 1 amp is coming down, this one, if in the given diagram, if the 1 amp is given down, then I3 current direction is mapping with this 1 amp, so we can write positive. But in this problem, I3 is clockwise, but I1 is going opposite. So we can directly write one equation. I3 is equal to minus 1 for this. This is minus 1. Why minus 1? It is opposite to this I3 actual direction. We have for all the three meshes, we assume clockwise direction, it is going upwards. So I3 is equal to minus 1 amp. So one equation we got from this. Next, we have these two equations. Another, for three meshes, three equations are required. One equation we got. So remaining two equations we have to obtain from applying KVL for mesh 1, applying KVL for mesh 2. So how to apply KVL for mesh 1? See, for mesh 1, okay, sum of resistance in mesh 1. What is sum of resistance in mesh 1? 5 plus 1 is 6I1. 5 plus 1 is 6I1. And you have to subtract opposite current. 6I1 common to 1 and 2, it is minus 5. Common to 1 and 2 is minus 5. And common to 1 and 3 is 0 because this is separate, this is separate. So 0 I3, 6I1 minus 5I2, 6I1 minus 5I2 minus 0 I3 is equal, this is in while writing KVL uh, the clockwise direction minus to plus. So if you bring it to right side, it becomes plus. So this is equation number 1. Okay. Similarly, apply KVL for mesh 2. Apply KVL for mesh 2. 5 I2 minus I1, 4.5 I2 because in the at the edge only one current, and 2 I2 minus I3 equal to 0. If you simplify, you'll get this. So which is common to 2 and 1 is minus 5. Sum of resistance in mesh 2. 5 plus 2, 7 plus 4.5, it is 11.5 I2, it is positive, and opposite current 2 I3. You have to subtract. Sum of resistance in mesh 2 is 11.5, and my common to 2 and 1 is minus 5. Common to 2 and 3 is minus 3. And that is equation number 2. Okay. And equation number 3, we have I3 because we cannot apply KVL for mesh 3 because there is a current source. So we can write 0 I1, 0 I2 plus 1 I3. Okay, 1 I3 is equal to minus 1. So I can write three equations. I can write three equations. So what is from equation number 1? What is the coefficient of 6? I1 is 6, then minus 5. Coefficient of I3 is not there, 0. Three meshes are there, I1, I2, I3. And voltage value is plus 20. From equation number 2, see the equation, minus 5, 11.5, minus 2, 0, 0, 1, minus 1. Please remember here, I told no, only if it is contain independent voltage source and resistance, you can use this inspection method. If there is a current source, okay, if there is a current source, don't write here common to 3 and 2 is same as common to 3 and 1. You cannot write this because this is a current source. You cannot directly write this equation. Okay, so for that method, you should know both the methods. If they ask only voltage source and resistance, it is very easy. If there is a current source, don't follow that. See here you can see 6 sum of resistance in mesh 1, sum of resistance in mesh 2. Only first equation and second equation it applies. For third mesh, actually current source is there. So common to 2 and 3 is not same as common to 3 and 2 because we have not applied any KVL for this. Okay, so that's why now you can solve this equation using calculator. Okay, so how to do this using calculator? So in the calculator, you have to go to mode, equation number 5, second 3 unknown variables. So enter 6 is equal to minus 5 is equal to 0 is equal to 20 is equal to minus 5 is equal to 11.5 is equal to minus 2 is equal to 0 is equal to 0 is equal to 0 is equal to 1 is equal to minus 1. If you enter all the values, now if you click is equal to, it will give x. X you should get 5, y you should get 2, z you should get minus 1. 5, 2, minus 1. We got same answer, 5 minus 2 minus 1. So this is how to solve the problem. This is the second the problem number